So we're going to do that same problem that we did in the last video, but we're going to use our calculator, and it's going to take about a fraction of the time. So here's our system, and I want another way to write it. We wrote it in matrix form, in the augmented matrix form, but another way you can write that, or write this, is like this. I can write out just the coefficients on my x, y, and z. Alright, so that's just sort of the coefficients of my x, my y, and my z. And then I can multiply it by this 3 by 1 matrix called x, y, z. And then I can set that equal to the answer matrix, which is 7, 14, and 3. So what I have here is called a matrix equation, and if we sort of call, first of all, notice that this multiplication makes sense because this is a 3 by 3, this is a 3 by 1, and so those match up, so the multiplication can happen, and the result is a 3 by 1, as it did happen. But I'm going to call this white matrix here an A. I'm going to call this matrix here an X, the XYZ one an X, and then I'm going to call this answer over here, we'll call it just a lowercase b. Now of course they're all matrices, right, but it's kind of easier to see in this form. AX equals B. So what are we really looking for? We're obviously looking for this one, right? We're looking for X, Y, and Z, so we want to solve for X rather. And we're using matrices in it here, but let's go back to go back to algebra. If I give you like 4x is equal to 8, right? How do you solve that? You multiply by the multiplicative inverse of 4. The multiplicative inverse of 4 is 1/4. And you do that because you want to turn that coefficient into a 1. And 1/4 is what does that. And so then you get your answer. You get your answer being 2. So we're going to do the same thing over here. We have already talked about what inverses are. If I just multiply both sides by A inverse, A inverse here, then what happens is that I can group my A inverse with my A, and we know that when you multiply inverses together, you get the identity, right? So 1 is the identity when we're multiplying numbers, right? But for matrices, the identity is the matrix, the 1, 0, 0, 0, this one with all the, let me write it over here. The identity is, right? That acts as 1 in 3 by 3 matrices. And so this is going to produce our identity, which is going to produce our x. And so over on the right hand side, of course, we've got A inverse B, and all that leads us to the conclusion that if we want our answer, we just need to go into our calculator and punch in A inverse B. So first we're going to go to our calculator, and I've already got it set up just to save time. If you go to and look at my matrix A, you'll see that it's set up, it's all inputted correctly. If I go look at matrix B, that too is set up correctly. And so to get my answers, I just go to the quit screen, and I call matrix A, I hit the inverse button, and then I go call matrix B, and we get our answers. So x equals x, which of course is really this, right, is equal to 2, negative 1, 3. So I'm sure you like that way much better than when we did row operations. But in any case, of course this is quick and easy if you have a calculator on you and if you're allowed to use a calculator. One thing I want to point out that's important. See how I multiplied on the left by A inverse? I have to multiply on the left by A inverse here as well, because if I don't, I'm not guaranteed that the multiplication can happen. Remember, things have to be set up just right in terms of the dimensions of the matrices to work. And only if you multiply on the left on both sides will it work.